So this video is going to be made up of two different types of questions. I'll deal with this one first and then I'll explain the second one and we'll go through that. They're actually kind of similar enough. Okay, so in the first one, find x and y if x plus 2i plus 2 times 3 minus 5yi equals 8 minus 13. It sounds like a bit of a tongue twister when you explain it, but it's not that difficult. Now, if you look at the equation itself, we actually have three letters. We have x, we have I, y, and we also have another I and another I over here. Now, because it's complex numbers, we know the i's are going to be there. That's okay, they're not variables, so we can just deal with that. But we do have an x and a y that are variables. Now, if you've done algebra so far, which you should have done at this stage and have a good understanding of it, if you're trying to find two variables, you need to have two equations. We have only one equation. Okay, so what we're going to do is try and use our knowledge of complex numbers to try and create another equation as well as this one. Okay, so the first thing we want to do is just clean this top line up a small bit. So x plus 2i, there's not much there. X plus 2i plus 2 3's is 6. 2 by minus 5yi is minus 10yi, and that is equal to 8 minus 13i. Okay, now that's simple enough. That's just expanding one bracket. Now what I'm going to do next is leave this right hand side now as a reference, but I'm going to try and sort this left hand side out so that like terms are together. Now we have an x and we have a 6, but there's no i's. So what I'm going to do is put those just on one side just to make it a bit easier for a second. X plus 6. We have a plus 2i and a minus 10yi. They both have i's, so they're going to go on the right hand side. So plus 2i minus 10yi, and that's equal to 8 minus 13i. Now, they're not fully like terms, but they're kind of like terms. This x, there's no I, so it's a real number. 6 is a real number. Plus 2i, because of the I, that's imaginary, and because that has an I, that's also imaginary. So now we have a real section and we have an imaginary section. Okay, so from the last couple of videos you will spot the left hand side will always be the real, the right hand side will be the imaginary. Now if you look at the right hand side of the equation, we have 8, which doesn't have an I, so that means that that part is real. And on the right hand side we have minus 13, but it has an I next to it, so that's going to be the imaginary part. So now on the next line I'm going to keep the reals with the reals. X plus 6. I'm going to take out I as a common factor here. So I'll have plus 2 minus 10y times I equals 8 minus 13i. And now I have a real section properly and a real section over here. The imaginary section on the right, now that I factor out the I, is going to be the same as this imaginary section, minus 13. Now, this is where our two equations are going to come from. So, the real has to equal the real on the left has to be equal to the real on the right, because it's an equation, it's equals. So, we have x plus 6 equals 8. X equals 8, take away 6, x equals 2. So that's our first one sorted. And now on the other side, the imaginary has to equal the imaginary. So 2 minus 10y from the left hand side has to equal minus 13 on the other side. We've got the x. Now we're trying to solve for y. So I bring the 2 over and across. Minus 10y equals minus 13. Plus 2 comes over and becomes minus 2. Minus 10y equals minus 15. That's a minus y, that's minus 15. We want positive y, so I can change signs, which is the same as multiplying by minus 1 on both sides. So you get 10y equals 15, and just through division, y equals 15 over 10, y equals 3 over 2. So there's my two answers. So from one equation, I've created two equations from my knowledge of complex numbers. Reals equal reals, imaginary equals imaginaries. So our second example, given that z plus 1 multiplied by 2 minus I equals 3 minus 4i, find z in the form x plus yi. So basically we need to try and find z on its own. Now, again, when you're trying to solve algebra, you always want to try and isolate the term you want on its own. So we want to try and get that z plus 1 on its own. Or sorry, z on its own initially. At the end, sorry, z at the end, but the z plus 1 now is the first thing we're going to try and get on its own. If I can get this 2 minus I away, then I've got z plus 1 on its own already. Because these are multiplied, I can divide this to get rid of it. So what I'm going to do, z plus 1 equals 3 minus 4i divided by 2 minus I. So now the z is almost on its own. If we can fix this side and then take away 1, we're sorted. But this is going to cause a problem. We're now dividing by a complex number. Now dividing by a complex number goes back to a previous video which included the complex conjugate. We need to try and find the complex conjugate of this. Now, the conjugate is the same as the normal complex number, except the imaginary part is changed signs. If you're stuck for that, you can look up this in the channel and you will find the complex conjugate video on how to work that out. So what I need to do is multiply above and below by 2 plus I, because that's the complex conjugate. So I'll work it out. 3 minus 4i multiplied by 2 plus I, all divided by 2 minus I, 2 plus I. By multiplying this out, 3 2s is 6, 3 by I is 3i, minus 4i by 2 is minus 8i, minus 4i by positive I is minus 4i squared, I squared. Another important part we've met before, I squared equals minus 1. So that's a bit we're going to change in a second. All divided by 2 by 2 is 4, 2 by I is 2i, minus I by 2 is minus 2i, minus I by plus I is minus I squared, again I squared. The next thing we want to do is input this, substitute the I squared in both cases. So now we've got 6 plus 3i minus 8i minus 4 times minus 1, all divided by plus 2i minus 2i, cancel. So we have 4 minus 1. Now don't forget all along, that is equal to z plus 1 the whole way down. Now I didn't write it just to make it easier, it's quicker to write, but don't forget that all of this equation is equal to z plus 1. So now the top line, 6 plus 3i minus 8i is minus 5i, and minus 4 by minus 1 is plus 4, all over 4 minus 1 is plus 1, 4 plus 1, 6 plus 4 is 10, minus 5i divided by 5. Okay, so now I can divide the 5 into everything up here. I'll do it on the side just to make it a bit easier. 5 goes into 10 twice. 5 goes into minus 5 minus 1. Okay, so that this right hand side has now been broken down as simple as 2 minus 1i, or 2 minus I, whichever you prefer. But this whole equation is actually equal to z plus 1. So z plus 1 equals 2 minus I, or 2 minus 1i, whichever you prefer. I'm trying to get z on its own. So z equals 2 minus I, plus 1 comes over and becomes minus 1. This minus 1 is a real number, so the real is taken away from the real. So in the end, z equals 1 minus I. 2 take away 1 is 1, minus I stays the same. And now z equals 1 minus I is of the form x plus yi. A number minus a number I. And that's this video.